Let's look at a few word problems that involve rational expressions or mostly rational equations. First question, in still water, your average canoeing rate is 3 miles per hour. It takes you the same amount of time to travel 10 miles downstream with the current as 2 miles upstream against the current. What is the rate of the water's current? Well, we can let R or X represent the rate of the water's current. We need to figure out what formula to use. Right, we need to use distance equal to rate times time. It says it takes you the same amount of time to travel. So we can solve our equation for time. So in other words, we're using d over r in our setup. Now let's set up each one of our parts, starting with the information about going downstream. We know the distance downstream is 10 miles, so that goes on top. And the rate, we know it's 3 miles per hour going downstream with the current. If you're going downstream, then your speed will increase. The water's current, I might have said wind, I'm sorry, I meant the water. The water's current helps you go faster. So we can denote the rate as 3 plus r, or 3 plus x if you want. Going upstream takes 2 miles, so that's our distance. And we know our rate is 3 miles per hour. Now, if you're going upstream against the current, you're losing speed. Losing speed means we need to subtract x. Now, since both of these occur in the same time, these two fractions are actually equal to each other. So we have 10 over 3 plus x equal to 2 over 3 minus x. Of course, you know how to solve a proportion. Right, you're right, the first step is cross multiply. We have 2 times in parentheses 3 plus x equal to 10 times in parentheses 3 minus x. Distribute the 2 and the 10 out. We have 6 plus 2x on the left-hand side equal to 30 minus 10x on the right-hand side. We need to solve for x. You can move the x on the left or the right-hand side. It's up to you. I added 10x to both sides. So that will give us 6 plus 12x equal to 30. Right, at this stage, subtract 6 from both sides. Oops, excuse me. So we have 12x equal to 24. The last step, divide both sides by 12. Giving us x equal to 2. Therefore, the rate of the water's current is 2 miles per hour. This problem involved just basic common sense. You know that going downstream means your speed will increase, and this could also apply to problems involving airplanes as well, where you're going against the wind, which would be analogous to upstream, or you're going with the wind, which would be the same as downstream. Let's look at one more word problem. Question 2. One person can paint the outside of a house in 8 hours. The second person can do it in 4 hours. How long will it take them to do the job if they work together? Well, one person can do a job in 8 hours. So his rate would be 1 over 8. The second person can do the job in 4 hours. So that person's rate is 1 job in 4 hours. How long will it take them to do the job if they work together? Means an equal sign. And on the other side, we're trying to figure out how long it would take them to do one job. We can represent that time as x. Now we have a rational equation that we can solve. The first step is to find the least common denominator. Right, the LCD among these three denominators is 8x. Next step, multiply each part by 8x. With each part, see what can cancel. The first part, the 8's can cancel, leaving us with just x. The second part, the 4 can go into 8 2 times, leaving us with 2x. And on the last part, the x's cancel out, leaving us with just 8. At this point, we can combine the x's together, giving us 3x equal to 8. And then just simply divide both sides by 3. Changing our answer into a mixed number will give us 2 2/3. So together, they can paint the house in 2 2/3 hours. And that makes sense. If two people are working together to accomplish one job, it should take less time than if they were to do the job separately. This concludes our discussion on word problems involving rational expressions or equations.